Okay, let it be. Yes, students, focus mode is on. Nobody will watch you. Only I can watch you. So please turn on your camera.
No, my camera is not working.
Heba, are you there? Should I start the carbonates compound chapter? The last topic that we have studied, can you tell me? No, Hiba, your voice is not coming. Join again if you are facing problem of not, if your mic is not, if you are means, if you are not able to unmute your mic, so please join it again, okay? Okay. So I think we have started carbonates compound chapter in the previous class, and according to me that I have teach you what Abdullah Ashraf will help me to. Yes, Abdullah, can you tell me that last topic that
Sir, I guess, yeah, sir, we're here only. Good morning, by the way. Sorry, good evening. Sorry.
so we have studied this one. I think we have studied the electronic configuration.
Yeah, sorry, electronic configuration. I'm sorry. And sorry for joining late. Actually, I
Okay,
joined the
I remember now. I
other.
remember that I told you that that we're going to discuss this one. Okay, that why carbon is so. If I talk about that, why carbon is so versatile in nature. Why carbon is able to make large number of compounds. Okay, so let's start this one. That why carbon is able to make large number of compounds. Okay, so first of all, you know that carbon is the first element that is going to be to have the smallest size atom, which is going to have the 4 electron in its outermost shell. Okay, this is the first, or we can say that carbon is the first atom. Carbon is the first atom that is going to have 4 electron in its outermost shell. Okay, 4 electron in its outermost shells. The next one is silicon. Silicon is the second atom that is going to have the 4 electron in its outermost shell, but it is bigger in size than carbon. It is bigger in size than carbon. Okay, so if it is being asked in the examination that both carbon and silicon are tetravalent, but carbon is able to make large number of compounds, but silicon does not make large number of compounds. Why is it so? The reason behind this, first of all, the first reason is a small size. A small size of carbon atom of carbon, then silicon. And what is this? What is helping here? How can you say that? How can you say here that silicon is helping? And we can say that how can you say that if the silicon is bigger in size and carbon is smaller in size, it is going to make the stronger bond, or the compound formed by carbon is more stable. So you can see here that this is a nucleus that is going to have the 6 proton positively charged. And if let's suppose, okay, if let's suppose, if I'm talking that it is going to make bond with hydrogen atoms, okay, one hydrogen atoms, they are going to make bonds like this way, okay, and here this silicon is also going to make bond with 4 hydrogen atoms. So you will feel here and you will find here that the distance to the bonded pair of electron is more in silicon as comparison to the distance to the bonded pair of electrons in carbon with the nucleus is less, because who is going to hold the bonded pair of electrons? Silicon is going to hold the bonded pair of electrons. So we can say that a small size of carbon help the carbon atoms to make stable bonds. Okay, got it? Here, the effective nuclear force on this bounded pair of electron is more as comparison to here the force of attraction bounded pair of electrons. Okay, so effective nuclear force on the bounded pair of electron is less. Okay, you understood? Understood, everybody? Why the force here is less and why the force here is more? Because they are closer to the nucleus. They are closer to the nucleus because of a small size. There are two shells only, so it is closer to the nucleus. You understood, everybody?
Yes, sir.
Okay. Now here it can comes to your mind that both silicons and carbon are small in size. Well, sorry, carbon is smaller in size, and silicon is greater in size, or we can say bigger in size as comparison to that of carbon. Okay. Now you can see here that the number of nucleus or number of proton present in this carbon atom is 6, and number of proton present in this silicon atom is 14. It is 8 more than that of carbon. So we can say that silicon is going to have more powerful nucleus than that of carbon. So still, how we can say that, let it be, it is going to have bigger in size, let it be, but it is going to have more powerful nucleus, so it can balance that force. But here is one thing you need to note here, that when these electrons that are present in the inner shells, like in the silicon, that is the 2 electrons, and these 8 electrons in the second shell. Okay, and this is the third shell of silicon. So these 8 electrons, okay, these electrons when revolve around the nucleus, okay, they are just, they are not able to, we can say that the positive charge of this nucleus is not able to reach to this bonded pair of electrons, to the outermost shells electrons. Still, it is going to have the powerful nucleus, 14 electron, but its reach or its power will not be able to reach to this one, because they are just revolving like this, and they are just forming the clouds. They are just forming the cloud like this, and the electron will not be able to reach. This is similar to that one, that for example, if you are sitting here, okay, and there are clouds, okay, clouds, the sun radiation will not be able to reach to you, because the clouds are making a barrier between the sun rays and you. Okay, a similar condition is that if you are having a fan blade, okay, if you are having two fan blades, and if it is rotating like this, then you are able to see the ceilings more clearly rotating. But if I increases the number of blades in the fans, right, I'm increasing the number of blades in the fan, and if it is spinning, then you will not be able, this ceiling will not be appear clearly. Means this area that was visible to you in two blades will become more blur in as comparison to the when it is going to have two blades only. The similar case is this when these electrons start revolving, okay, like this. So the nucleus power will not be able to reach to this bonded pair of electrons. So the bond is weaker in silicon. However, in carbon, there are two electrons only. They are not able to shield. So the nucleus is easily visible to these electrons. So they are tightly bonded or tightly held by this nucleus. So effective nuclear force is more in carbon to the bonded pair of electron as comparison to that of silicon. Still, if it is having 14 proton. Understood? Understood, everyone?
Yes, sir.
Okay. So you have to write here this one, that due to small size, note it down, due to small size, the effective nuclear force in carbon to the bonded pair of electron is more. Note it down. Due to small size, the effective nuclear force in carbon to the bonded pair of electron is more. Note it down. Due to small size, the effective nuclear force in carbon to bonded pair of electron is more. This will help to make more stable bond or a stronger bond. The second reason is because of poor shielding effect. Poor shielding means, what is that shielding? Shielding is this one that these inner electrons are doing. So they are able to shield the charge of this nucleus, and this it is not able to reach to this one. But here these electrons are only two and they are not able to shield the effective charge or the positive charge to these bonded pair of electrons. So here we can say that they are poor in shielding. They are not able to shield because they are two electrons only. Okay, but there are 8 electrons, so they are able to shield well. So the positive charge of this nucleus is not able to reach to this bonded pair of electrons. So note it down here that second reason is because of the poor shielding effect of carbon electron than silicon. Note it down fast. Carbon two electrons are not able to shield properly. Okay. Students, I want to say something to you that if you are able to turn on your camera, please turn on your camera, because it will definitely help me to, if I'm able to see your face expression, whether you are getting things properly or not, if you are concentrating on this, on what I'm saying right now or not, so it will be much beneficial for you. Will we give, means if a person or a student is having their camera on, we will specifically look to them that whether they are getting on or not. Okay, their fixed face expression is going to help us to teach them in a better manner. Okay, so please turn on your camera. It will definitely help us to teach you in better manner. Okay, your face expressions are important for us. If you are having your camera on, this will help us to teach you in better manner. Okay, if a person is looking somewhere, okay, we can able to see him or her, whether she is concentrating to us or not, whether she's looking on the screen. If she's not able to get something, we can just understand with her face expression, okay, or with his face expression. So please turn on your camera if possible. You are in focus mode. Nobody can see you. Only I can see you, okay?
Yes, sir.
Done? Done?
Yes, sir.
Okay. So let's move further. The second things that we can say here is the covalent bond. Covalent bond is the second strongest bond that is formed by carbon atoms. Okay, carbon is going to have 4 electrons in its outermost shell. Okay, 2 in the first and 4 in the second shell. Okay, so it is going to have 4 electrons in its outermost shells. It can neither lose 4 electrons nor it gain 4 electrons. Why? Why it cannot gain 4 electrons? Why it cannot lose 4 electrons? Because it is very difficult. Let me explain you why it is difficult for carbon atom to lose 4 electrons completely and to gain 4 electrons completely in order to complete its octet. For example, if I'm talking about this NaCl, Na is sodium is going to have electronic configuration 281. Okay, and that of chlorine is going to have electronic configuration 287. So it is going to have 1 electron in its outermost shell, and this is going to have 7 electrons in its outermost shells. Now, what is going to happen here is this will lose 1 electrons, okay, and will get 2 comma 8. And here, if it is going to have 2, if it is gaining 1 electron, it is also going to have the 8 electrons in outermost shells. So here sodium is completely donating 1 electron to this one in order to attain the stable electronic configuration, that of neon. And this is chlorine is going to get 1 electron completely forever and forming Cl minus ion, just because it wants to have the electronic configuration to the nearest noble gas, that is argon. But what would happen in case of carbon? So here is carbon atoms, and this carbon atom, 1, 2, 3, 4, 4 electron, it is going to carry 4 electrons in its outermost shells. What would happen if it continuously loses 4 electrons? Because it is only gaining 1, it is only losing 1. 1 or 2 is okay, but losing 4 electrons from a same shells, which is not means which is smaller in size, the atom which is already smaller in size, it is very difficult. Why? Let me explain you. Now, for example, if this carbon atom is losing its electrons, let this is the first carbon atoms, okay, here, and this is like if it is the original carbon atom, this is going to have 1, 2, 3, 4 electrons. Now it is going to have 6 proton and 6 electrons, total 6 proton and 6 electrons. But let's suppose it loses one of its electron and it becomes C plus. Okay, so the size of the atoms will decreases. Size of the atom will decreases. Why? Because here now 6 protons are attracting the 5 electrons. 6 protons are attracting the 5 electrons. Greater number of protons when attract the lesser number of electrons, they will
Can it,
attract it with more power, and it will result in shrinking of atoms. So now the amount of energy that here for removing the one electron is required. For example, let suppose here 1000 joule energy is being required to remove one electrons from here. Now for the next electron, it will not be the 1000, it will be in the proportionate, in the power, it will be more than 5000, 6000, 7000, means it will be exponentially increasing. It will not be same that for removing one electron, if it is taking 1000, so if you are removing the next electron, it will require now. No, why? Because if this electron is now very closer to the nucleus, now it will take more energy, it will not take the next 1000 energy. Now, if you let's suppose remove the one electron from it, from this one, okay, then the size of the atom further shrink, okay. And if you keep on doing this one, so the atom size will keep on decreasing, and a larger amount of energy will be required to remove all 4 electrons, which is not practically possible. So carbon cannot lose 4 electrons and will form C4 positive. It cannot lose the 4 electrons to form C4 positive, nor it can gain. Here 6 protons are attracting the 4 electrons, and if it able to lose one more electron, then here 6 proton will be attracting the 3 electrons. So more protons are attracting the lesser number of electrons. As a result of it, the atom size will decreases, and we will say here that the size means as the atoms keep on shrinking, more and more energy will be required to remove the all 4 electrons. So it is not practically possible. So that's why carbon never forms C4 positive ion. And similarly, if it continuously gaining electrons, for example, okay, so if it continuously gains electrons, the size of the atoms will increases. Okay, this is 2 electrons, this is 4. Let's suppose 1, 2, 3, 4, it gains 1 electrons, so it will become 5. Now if it is continuously gaining, then 1,
it
2,
would be
3,
it would
4,
be
5,
difficult
6.
for the nucleus
Yes,
to
and
hold on
size
to
of,
like
yeah,
more
yeah.
electrons.
The size of the atom keep on increasing. Moreover, the repulsion between these electrons will be more. Why? Because electron repel each other. If there are 4 electrons already present, if you are adding more and more electrons, so in that shell, the electron repulsion will be increased. And moreover, this nucleus is going to have only 6 protons. So if we add 4 extra electron to it, now it is having 6 electrons in the normal condition. When you add 4 extra electron to it, it will going to have 10 electrons. So 6 protons are not able to hold 10 electrons. So it is very difficult for the carbon atom to gain 4 electron and 4 C4 minus ion. So it is not possible for carbon to lose 4 and to gain 4. So what it will do in order to complete its octet, because every atom wants to have the nearest noble gas electronic configuration to attain the stability. So what will carbon do in order to attain stability here? It will start sharing of electrons. Here, when the carbon starts sharing electrons, for example, in case of carbon dioxide, CO2. Okay, so here is oxygen atoms. Here is one more oxygen atom, and these are the 4 atoms of carbon. Okay, let I'm writing here like this way, and here are the 6 oxygen atoms. Okay, 6 oxygen atoms are there. Okay, electronic configuration of oxygen is 2,6. Atomic number is 8. So this is 6 electron outermost shells, 2,6. So what it will do? It will start sharing. So it will do like this. It will start doing sharing 2 electrons like this way. 2 electrons of oxygen. Here it will complete its octet 1, 2, 3, 4, 5, 6. And when these 2 electrons of carbon orbits in this one, the oxygen is also going to have the 8 electrons. So this is the structure of CO2 and how it is being completed. Okay. Now, similarly, if this is hydrogen atoms, this is carbon 1, 2, 3, 4, and these are the hydrogen. Hydrogen has only 1 electron in its outermost shell. So this is the structure of methane, CH4. This is how carbon is sharing the electrons, one electrons. Okay. It is having 8 electrons now, and this is hydrogen. It is going to have two electrons in their outermost shells. So this is how the structure of methane. This is methane. CH4 is methane, and this is CO2, carbon dioxide, carbon dioxide. So the bond formed by sharing of electron is called covalent bond, and it is not a weaker bond. After the ionic bond, the second strongest bond in the chemistry is the covalent bond. So covalent bond is the second strongest bond, means carbon is forming bond by sharing electrons, and this is the second advantage, that it is forming the covalent bond, and covalent bond is not a weaker bond, so it is a stronger bond. So the bond formed by carbon is stronger. Why? Because it is making using covalent bond. The first reason was why it is able to make large number of compounds. The first reason was a small size. The second reason was tetravalency. Tetravalency. Because of tetravalency, it is able to make four atoms. It can make bond with four similar atoms or different atoms at a single time. Okay. Eh, okay. So we can say that because of the 4 electron in its outermost shell, it can make bond with 4. So this is an advantage, that if, for example, if I'm saying that this is chlorine atom Cl, so it is going to have 7 electrons in its outermost shell. 287 is the electronic configuration of chlorine. So here it will not make bond with 7 atoms. It will make bond with one more chlorine. Okay, because it requires only 1 electrons to complete its octet. So it will share with one atom. So it will make only one bond. Chlorine can make only one bond because it is going to have 287 and require only 1 electrons. But since it requires 4 more electrons, so it can make 4 more bonds. So here we can say that due to tetravalency, it is able to make large number of compounds. Third is the covalent bond, which is the second strongest bond. And the fourth one is catenation. Catenation is a self-linking property of an element. What is catenation? It is the self-linking property of an element to which it can make bonds in which an atoms can make bonds with similar to its own kinds. Means, for example, oxygen show catenation property up to 3 elements. Means in ozone, oxygen make bonds with O3. Sulfur make S8, means 8 sulfur atom combined together, they form S8 molecules. So sulfur show catenation property up to 8 atoms. Like similarly, chlorine show catenation property up to 2 atoms, Cl2. Hydrogen show catenation property up to 2 atoms, H2. So they are different atoms that are showing catenation property up to 6 to 7 elements. Okay. But carbon can show because of the above reason, which these elements don't have. Okay. Sulfur don't have this a small size. Oxygen don't have the small. So oxygen, if it is having the small size, let if it is having small size, but rather it is not having the 8 electrons, sorry, 4 electrons outermost shell. It is not tetravalent. So we can say that only this is the carbon that is going to have all these specific properties. And because of the above 3 reason, that is small size, tetravalency, and covalent bond, okay, we can say that carbon show this catenation property, this self-linking property to the maximum extent. Carbon show this catenation property to the maximum extent. Okay, because of the above 3 reasons. You understood? Understood, everybody?
Yes,
So because of the above 3 reasons, carbon is able to make large number of compounds. Okay. So catenation is not shown by the carbon atoms. It is also shown by other element, but catenation's property shown by carbon is the maximum. Means carbon show this self-linking property to the maximum extent. Thousands of carbon atoms can join together, and they can join together and they can form large number of compounds. They can join in a chain. They can join in a branch like this. Okay. They can join in a rings like this. Okay. They can join in with double bond, triple bond, single bond. So it's a choice of carbon. Okay. It can make bonds of any types. Okay. So this is very important for us to understood that why carbon is showing such large number of self-linking property, just because of the above 3 reasons: small size, tetravalency, and covalent bond. So note about this covalent bond, that covalent bond, since carbon has 4 valence electrons in its outermost shells, so it make bonds by sharing 4 electrons to complete its octet. Such bond is called covalent bond. Covalent bond is stable and the second strongest bond after the ionic bond. That's why it forms a stable compound. Note it down. Done?
Sir. Oh, 1 minute.
Yeah.
Done, sir.
Done?
Done, sir. Yes, sir.
Okay. Next, catenation property. Note it down. What is catenation property? Note it down. Catenation property, it is a self-linking property of an element by which it can make bond with its own kind is a self-linking property of an element done. Note it down. But in case of carbon, due to small size, covalent bond, and tetravalency, carbon show catenation property to the maximum extent.
Done, sir.
Done?
Yes, sir.
Okay. So should I move forward? Abdullah, turn on your camera.
Sir, I have to like change my device then.
Have you done?
Yes, sir.
Yes, sir.
Yes.
Okay. Let's move further. So the question comes in examinations that both silicon and carbon are tetravalent, but silicon can make chain up to 7 to 8 silicon atom bonded together, while the carbon can make chain up to hundred of thousands of carbon atoms bonded together. So what's the reason behind this is that because of a small size of carbon, carbon has 2 shells and silicon has 3 shells. The bonded pair of electron has more effective nuclear force. Okay. Then the bonded pair of electrons in silicon. The bonded pair of electrons, the bonded pair of electron has more effective nuclear force in carbon than the bonded pair of electrons in silicon. As a result, more stable bond is found in carbon and silicon. Okay, note it down. The next is effective nuclear force. We called it Z effect in chemistry. The nuclear force is called Z effect. Okay, so here it is written that in carbon the shielding effect is less than silicon. Okay, or we can say that in carbon the shielding effect is poor. Instead of this less word, you can use poor than silicon. So the effective nuclear force, which is called Z effect, in carbon is more than the silicon to the bonded pair of electrons. Note it down.
Sir.
Yes, are you saying something, Karishma?
Yeah, yes, sir. Sir, second point is a part of question or not?
This is the question. The whole. Yes, it is a part of answer. This is the first point, and this is the second point.
Oh, okay, sir.
So if it is asked in 4 marks or 3 marks, you need to write in two points. If it is being asked only with 2 marks, then write the first points only. Okay. So it depends on
Oh,
the type of question, the how many marks question is being asked. Okay. And dear students, you need to note it down that sometimes you write the answer in the test and you probably are not sure of writing what you are writing. Okay. You are just having some misconception that it can be, it can't be, but you write it. Okay. For example, if the teacher asks you to write, means this question is being asked in the examination. Okay. And you write the answer, you forgot this point and you are not sure, but you are having in your mind that says sir has taught us a second point, something like shielding effect, but we don't know which is going to have poor, which is going to have high shielding effect, but means you are just having misconception in this point. So don't write this point. Okay, if you write this point only, then it is sufficient. Means whatever you are writing, like for example, let me explain you. For example, if a question is being asked and you write only 3 points, okay, 1 point, 2 point, and 3 points, you can write the two more points, okay, 2 more points, but you write the 3 points, okay, and you are sure in these 3 points, okay, you are sure in these 3 points that this is 100% correct. So write this only, that the point that you are writing right now. Okay, don't write that points. Keep in mind that don't write that points in which you are not sure. Because sometimes the if you write this one, teacher think that the student know the answer. If it is of 3 marks, the teacher can give you the 3 marks. But if you write the two more points, but it is going to have some improper information, or I can say that it is having some information which is not correct. Okay. So if it is being written here, but you are not writing right correctly, so I will use the red pen here. Okay. I will use the red pen that this is not correct, or I'm writing it not proper. Okay. So I will not give you 3 marks for this question. However, if you don't write this point, I will give you 3 marks for these points. But since you have written some incorrect things in misinformation here, which is not correct, so I will give you some 2.5 or 2 marks for this one, or 2 marks. Why? Because you have written something. When a red pen is being marked, when a red pen is being used, it means the marks is being deducted. So write each and every answer. We are just writing, we are just giving you more points. We are just helping you to write the answer properly in an appropriate manner. But write only those points in which you are 100% sure. And moreover, try to write the correct spellings of each and everything. If you are not having, if you are, for example, if you are confused in having some spelling whether this is correct or not, so don't write that spelling. Use different word to for that statement. Okay. If you are, it means your writing skills must be better. Okay. If you are writing some statements, only write those point, or only those words which are 100% correct. The teacher can give you the full marks if you don't write extra. If you write 3 points, it's okay, the teacher can give you the 3 marks. But try to write each and everything properly. Most of the student I used to check their copy, they are not sure about what they are writing, but they are writing something. They think that they are writing, we need to fill 4, 5, 6 lines for this answer, and whether it is correct or not. No, write only those words that are important and that is 100% correct. So note it down. Done. Okay. If someone is having, means, is there anyone who is still writing?
No, sir.
Okay. So let the second point here is that the question is being asked sometimes that why carbon cannot form C4 positive and C4 negative. It is being asked in the previous to previous examinations that why carbon cannot form C4 positive and C4 negative. So the answer is that why carbon cannot lose 4 electrons. So the answer is, as the carbon start losing its electron, the size of the atom decreases because greater number of protons are attracting. Because greater number of protons, 6 protons are attracting the lesser number of electrons. 6 proton, 4 electrons. So as it is, as the due to that, the size of the atom keeps on shrinking. The atoms will get smaller and smaller in size, and it is more difficult to remove all 4 electrons. So the size of atom decreases, which make it hard to lose 4 electrons. So that's why it cannot lose 4 electrons. So note it down. Why carbon cannot lose? Why carbon cannot lose its 4 electrons and form ionic bond? Done? I will check your copy on
Yes, sir.
Sunday, okay? Done?
Yes,
Yes.
sir.
Still writing?
No, sir, done.
Next is this is being if it is being asked that why carbon cannot gain four electrons, the powerful nucleus is being required to hold four electrons, which carbon don't have. Okay, so this is the reason. So conclusion, what is the conclusion? That carbon make covalent bonds. Okay, got it? Note it down, please, fast. Done? Done, everyone?
Yes, sir.
Okay, so let's move further. Here, we're going to know the structures. The electron dot structure is important. For example, if it is being asked to make the electron dot structure of NO2, O2, S8 molecule, S8, CO2. Okay. So how can we make the electron dot structure of this one? You know that every atom wants to be stable and wants to have the electronic configuration to the nearest noble gas. So for example, the nitrogen is going to have the atomic number 7 and its electronic configuration is 2, 5. So how many electrons does it wants to complete its octet? Tell me.
3.
3.
3.
So here this is nitrogen atom. It is going to have 5. Only the electron that are present in the outermost shell of an atom, we are going to represent that one only in the electron dot structure. Okay. We don't represent the innermost electrons, only the outermost shell electrons. So now if it is being required 3, so it will shares 3 electrons. So here because it required 3, so here it will share 3. The second nitrogen atom will be like this. Got it? And will make bond like this. This is the electron dot structure of N2. Okay. What is the electron dot structure of O2? O is how many electrons are present in the outermost shells of oxygen? Tell
2.
me how many electrons are
6.
present? 2, 3, 4, 5, 6.
6.
6.
6.
6. So how many it need to complete its octet?
2.
So here are the, it will share 2, 2 only because it required 2. So it will share 2. So here is another 1, 2, 3, 4. So it will be like this. 8. It will be like this. 8. Okay. Got it? Understood?
Yes, sir.
Okay. Next is if I'm having S8. So S8 molecule structure is like this. You need to make the structure if you want to make the structure of this one. Okay. So you have to make the structure like this. Means this is the point here that you need to put the S. 1, 2, 3, 4, 5, 6, 7, 8. You have to put the 8 S like this way. So you can make it like this way first. Okay. If you want to make the structure of S8, so you can mark it that one atom of sulfur should be here, one atom of sulfur should be here, one atom should be here. Okay. Like one atom of sulfur should be here, one atom should be here, one should be here, and one should be here. Now you can make S. One sulfur, second, third, fourth, fifth, sixth, seven, eight. Okay. Understood?
Yes.
Now how many electrons are present in the outermost shell of sulfur? Tell me fast, how many electrons are present in the outermost shell of sulfur? 286 electrons, 6. So it requires only two electrons will be shared. So the two electron that will be shared, we are just representing here. One for this sulfur, that's two electrons bonding will be there. So we have two electrons of everyone being shared, and remaining four of each you need to give it like this way. Four of each.
Why for it's only need two electrons, right, to complete the last cell?
Because the maximum electron that a second shell can have is 8. Third shell.
Yes, only need two, right? It's a 6.
Yes. So that's why it is sharing one here, one for this sulfur and one here. So it is sharing
So
with this one.
2, 2, 2, like
That
4.
it is going to share two electrons every sulfur atom. Let me explain
Oh,
you that one sulfur atoms, which one electron will be shared with this one electron will be shared with this one. Okay. So it is going to have 8 like this way.
okay, sir.
Now this is going to have 8 like this way. This is going to have 8 like this way. Okay, draw the structure of sulfur acid. It is important. Carbon dioxide we have done. Done?
Yes, sir.
Done everyone?
No, sir.
Right fast. Kiran, are you getting? Can you please turn on your camera? I need to talk to you.
So my internet is not so good, so if I turn on the camera, it will glitch a lot.
Okay. So are you getting?
Yes, sir, it's fine.
Okay. Are you having cold?
A bit.
Okay. You, Samina, are you getting?
Yes, sir.
Okay.
Done, sir.
Done?
Yes, sir.
Okay. So here is question in front of you, question number 10. Which of the following is the correct representation for electron dot structures of nitrogen? Hiba, are you saying something? You just unmuted yourself, but I didn't listen anything.
Yes, sir. The first 10th question answer is D.
Is A.
It's nitrogen will
Which is the correct option for question number 10?
it's D, right? I mean
Yeah, it will be D. Okay, because the 3 are being shared here and 2 here. So total nitrogen have 5. The 3 is being shared. So D is the correct option. Okay. Next. Question number 22. Which is the correct electron dot structure of carbon of water molecule? Which one is correct?
C.
Which one?
C.
C. Yeah, C is correct. Why C is correct? Here the 8 electrons are represented, but you can see here that it is similar like this. Okay. So here the 8 electrons. So 1 and oxygen have 6. Okay. 1, 2, 3, 4, 5, 6. Okay. And hydrogen has 1. So the hydrogen electron is represented here like this. So it's okay if they are representing like this. So this is going to have 8 and hydrogen is also going to have duplet. Okay. So it is also correct. But if you make it like this, if it is being asked in the examination, so you have to make it like this. Okay, you have to make it like this.
Yeah.
Okay, next. So electron dot structure is several times been asked. So you need to practice the electron dot structure of different types of molecule because it is important. It is so many times being asked in the examination. Okay. Like structure isomers of hexane. So sometime it is being asked that write down the electron dot structures also. For example, here you will study. Write down the electron dot structure of this isomers. You will going to study the isomers, what are isomers, and you will going to there are so many questions that is being asked, okay, in the examination related to electron dot structures. Next is allotropy. And allotropy we're going to discuss in the next class. So please write down the next topic of the class is allotropy. So we'll start the allotropy, allotropes of carbon in the next class, okay? So please note it down that why the next topic for the class is allotropes. And please, it is my request that all the students are being requested to join on time, okay? Don't be late, even for 5 minutes. Because we have back-to-back classes, like we are just ending the class right now, the next class will be started. Okay, so this is your fault that if you are not attending the whole class for an hour, it's your fault. Okay, let's practice one or two questions. So if it is being asked the structure of H2SO4, H2SO4, how will you make the structure of H2SO4? Sometimes Cl2 structure is being asked in the examination. So this is the structure of Cl2. One electron is being shared because chlorine is going to have already 7, so it is being sharing only 1 electrons. The structure of H2SO4 in the structure of H2SO4 is this. oxygen atoms, we can have, I can make it like this. This sulfur atom, it is going to have 6. So 1, 2, 3, 4, 5, 6. Now the 4 oxygen atoms will be 1, 2, 3, 4. Now one electron of this oxygen will be shared with this one, and one electron will be shared of this oxygen with this hydrogen. Like this way, okay? One electron of this sulfur will be shared like this way. And the 6 electrons, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is the electron dot structure of H2SO4. Here you will notice that central atom is going to have 12 electrons in its outermost shell. Sulfur can have more than 8 electrons in its outermost shells. So that's all for today. We'll meet you in the next one. Dear students, please note down the topic, that the next topic will be allotropy. Okay? Done, noted everybody?
Yes, sir.
Yes, sir.
Okay, so you may leave.
Thank
Sir, are
you,
you
sir.
sad that India lost?
You know, India lost. It's okay.
Sir,
Win and loss are the part of the
बहुत
game.
बुरा लग रहा है.
It's okay. These are the part of the game. Yes,
Okay,
Zainab.
sir, bye. Allah Hafiz.
Okay, take care. Yes, Zainab, have you prepared for the test? Zainab, have you prepared for the test?
Yes, sir.
Metals and non-metals?
Yes, sir.
Okay. So give me a minute. Please turn on your camera. Okay. So question number 4, which is the correct option? Tell me fast.